Okay, let's try that again. Good afternoon, everyone. How are you? Excellent. So my name is Derek Ferguson. I'm the head of engineering for JP Morgan Chase's Commercial Bank, and today's topic will be accelerating machine learning DevOps with Kubeflow. So just quick show of hands, and I think we're few enough in numbers that we can sort of customize this a little bit. How many folks attended Arun Gupta's presentation yesterday on machine learning on Kubernetes? Okay, 2 of you, all right. How about this? How many folks are already really familiar with Docker and Kubernetes? Oh, it's like a split vote. Okay, so here's the deal. So yesterday I was in Gupta's presentation, which was absolutely fabulous, and I thought to myself, if lots of folks attended that, this is going to be, the start of it might be rehashing some of that sort of stuff. So I thought we might spend some more time going deep into the areas towards the end, sort of a code level view at Kubeflow, and maybe sort of speed up the initial content on Kubernetes and Docker. How about this? Would anybody be averse to that sort of an approach? All right, so everybody's cool with like the code level stuff. That's what we'll hit. So the proposed agenda. Quickly about me and my project, just so you sort of get oriented in terms of the work that we've been doing, because we're going to use that as sort of a sample for the work you can do with this. Really quick coverage of the underlying technologies. Probably really quick coverage of the underlying technologies. Now I've sort of talked to you and gotten a sense of where the room's at. And then we'll talk all about Kubeflow. Specifically, how do you run this on-premise? So not in the public cloud, not on Google Cloud, which is sort of where Kubeflow most likes to run since it is Google technology, not Amazon Cloud, not Azure, but basically your own Kubernetes instance. That will be sort of the core focus of this. And then I'm going to go, there's a lot of stuff in Kubeflow. I'll sort of give you an overview of all of it, but I'm going to go really deep on Kubeflow pipelines, because I think that those are really sort of core to the Kubeflow experience and deliver, a good part of the value that's in Kubeflow. And then hopefully we'll end quick enough that we can have time for questions and answers. I'll try to finish around like maybe 5:05, so we got at least 5 minutes for questions. Everyone cool with that? Anyone not cool with that? Excellent. By the way, was anybody in Baruch's presentation right before this? Okay, good. Baruch is tremendously entertaining. I don't know if this will be as entertaining. Hopefully it will be as informative, but he's he's a funny guy. All right, so who am I? Head of Engineering, JP Morgan Chase Commercial Bank. There's my email address. If you have any comments, questions, concerns whatsoever, please do feel free to write me after the fact. Very happy to talk about this. Kubeflow is about 50% of my day job nowadays, so it's a topic that's near and dear to my heart. Also, I run a blog at that location, which is pretty much 100% about Kubeflow. What I've liked about it, some of the struggles I've had with it, all that sort of stuff. Please, visit that, give me your feedback, and go from there. Previously, interestingly enough, I was a tech evangelist in the Microsoft space before I came to work for Chase about a decade ago. I did a .NET magazine, wrote a couple books. I'm actually a lifelong Chicago native. For those of you who are here from out of town, I do apologize for the weather. It's normally not like this at all. Graduated DePaul. And actually, just in case we have some other Chicago natives, anyone here a former Interaccess customer? Not a one, darn it. Well, we started commercial DSL right here in Chicago, so I'm just saying. All right, so let's talk a little bit about City Scholars. So City Scholars is a partnership between the City of Chicago and the University of Illinois at Urbana-Champaign, which is one of the top 5 schools of computer science in the country, and about 50 different technology companies in Chicago. And what winds up happening is every year the students will work half-time during the spring with one of the big technology companies in Chicago, and they go to class half-time. Then in Chase's case, at least, they come back in the summer and they work full-time. The idea basically is to make Chicago, a compelling destination for our technology graduates after they graduate downstate, come to work in Chicago. This year, I own the project for Chase, and we've basically had 2 remits. One of which, build some great machine learning models for our business. So that's just basically saying, hey, there's a lot of things that the business can benefit from in machine learning, let's do that. But then a larger partnership with Chase and Google and Microsoft and Red Hat, who are the main sponsors for Kubeflow, is let's see what we can do to improve the state of machine learning DevOps for the industry as a whole. So let's talk a little bit about what the problem is that we're trying to solve. So when you think about data scientists and you hire them, they focus on machine learning code, writing code that does trainings. You can think about that as the orange box. And it would be great if that was all that there was to it. Companies went out, they hired tons and tons of data scientists, and they hired comparatively few DevOps folks to support those data scientists. That gets to be a problem because you can't really do machine learning without collecting a bunch of data, right? And who does the data collection? Typically you need some ops staff to support you in that. So now you've got data collection, which is the blue. Once you collect the data, you need to verify it. That requires some ops input. You need to set them up with analysis tools in order to do any of that work. You need to extract features, so you maybe have 1,000 different data points about your customers. You might only use 3 or 4 of them. Extracting that requires some operate input. Serving infrastructure, once all of the stuff is written and you need to run it someplace, you need to set up the infrastructure to run it. That needs some DevOps. And then monitoring, once it's up and running, you have to keep track of it. Who's going to do that? If you find that it's running slow, you need to go in, you need to tweak the machines. That's some resource management. That's more of an operate piece. And then in order to do that, you need the process management tools. So very quickly you see what you thought was going to be a relatively small task in orange, which is the bit that the data scientists do, has an awful lot of blue around it, which is the DevOps piece. So what we're looking for is something that will solve that blue for us. Now, given that you're sitting in a session where Kubeflow is in the name, no points for guessing that the solution we're going to show you for this is Kubeflow. And Kubeflow is basically enabling your machine learning workloads to run on Kubernetes flawlessly and hopefully easily. So since I'm not going to go and show you, as you might have guessed, a whole bunch of details about the sensitive financial models that we're putting together at Chase, what are we going to demonstrate this with? We'll use the fashion MNIST. Show of hands, does anybody not already know what the fashion MNIST is? Okay, all right, very quickly. So what we're going to do is we're going to train up, actually in the session, I've got everything running on my laptop, so this is going to be our on-premise Kubernetes cluster. We're going to train up a computer vision model to be able to recognize 10 different kinds of clothing. And that's the data set that allows us to do this is called the Fashion MNIST data set. It's got 60,000 training images and their labels and 10,000 test images and their labels. And the thing to understand about this is the way that this data comes to us is 784 position arrays containing numbers 0 through 255. So the 0 through 255 is basically the brightness of the images, and the 784 position array are the different pixels on the screen. Now the thing is, images typically aren't flat arrays, they're matrices. So one of the things that we're going to use Kubeflow pipelines to do is to take those arrays and bounce them into matrices. Data pre-processing, that's something you have to do in pretty much any sort of machine learning algo. Okay, so that's Fashion MNIST. All right, we'll go really quickly through the Docker and Kubernetes stuff. All right, so old days, 5 years ago, if you wanted to get infrastructure set up for your training, for example, you might ask somebody to set up a bunch of VMs for you. VMs, not very efficient because they duplicated the host operating system in each of the guest operating systems, and they duplicated the guest operating systems over and over again. So this was sort of the big problem with VMs. You had a lot of wasted space. So you're a DevOps person. You're sitting at your desk one day. Your data scientist calls you up and says, hey, I've got a great new model. Could you please set me up 10 virtual machines? Well, the thing is, A, you're probably not just sitting there waiting for somebody to give you work to do, right? You've got other stuff on the list. And in most organizations, setting up a virtual machine, there's a lot of stuff you need to go through. Besides just setting up the operating system, you have to set up special security software, you have to set up the networking, blah, 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 capacity management, so on and so forth. So setting up VMs takes a long time. Then we get into Docker. Hit this very quickly also. So with Docker, you've got this concept that you're not duplicating the host OS over and over again. In the guest OS, you basically have this containerization technology, which is able to say, look, there are some bits that are immutable and some bits that are immutable. I'm going to separate those two using a mechanism that doesn't require me to just duplicate it in order to keep it isolated. That allows you to fit a lot more instances of your application on the same physical hardware. So like, we're talking a couple of orders of magnitude here. Sometimes, you could go from just being able to get 10 virtual machines on one piece of hardware to being able to get 1,000 containers running the same software on it. The other thing about Docker is that it's inherently scriptable. So you start off with Docker files that basically say, start with this container image, put this stuff on it. And if you want to define another Docker image, you can basically say, start with this other Docker image and put this stuff on top of that. So because it's inherently scriptable, it's faster to set up. But it's still not quite as fast as it could be by itself, which is where we introduce Kubernetes. So with Kubernetes, you have this orchestration layer that sits on top of and works with containers, most often with Docker containers, right? So here the concept is, if you're going to be running 1,000 copies of a container, and that container is like, say, your latest web application, you should just be able to go to Kubernetes and say, hey, Kubernetes, I've got 10 pieces of hardware over here, all of which are running Kubernetes. Could you use those 10 servers and basically spin up 1,000 instances of my web app on it, my web app container? And it'll go out and it'll do that work for you. Other nifty thing it does, it'll do software load balancing. So once you're running this 1,000 instances of your application, it can figure out which ones are busy and which ones aren't busy. At a hardware level, it can actually monitor the resources. And as flow comes in, it can say, you know what? This new request is coming in. Let's not send that to the busy instances of the container. Let's send that to some of the less busy ones. So you got some nice software-based load balancing there. And then, last but not least, if you want to go from version 1.0 of your application up to version 1.1, you can tell Kubernetes, hey, I've got a new version of my software. Could you please start rolling this out? And it will do the grunt work that the operate staff used to have to do to say, okay, let's take this new version and put it on this server. Okay, we'll make sure that's okay. All right, now let's take down a few more of these containers. Let's put up the new version. Okay, that looks okay. It'll do these nice sort of gradual rollouts of your software if you want it to. And there's like 5 or 6 different strategies that just ship out of the box for different ways you can roll out new software. So Kubernetes turns out to be a really efficient way to manage containers. So now you're thinking, okay, so we go back to this case with our data scientist, and he wants to spin up a whole bunch of different containers that will run his model. Kubernetes seems like it fits the bill just out of the box. Boom, done deal. We can end the presentation now, right? Well, of course, it's not that easy. What are the challenges with just using Kubernetes raw to do machine learning? Well, to begin with, for most kinds of distributed machine learning tasks, network topology is extremely important, and it has to be conveyed to the parts of your machine learning. So in this case, I'm basically showing a distributed TensorFlow training, which has a master, and the master node needs to know where all of the different worker nodes are. All right, fine. So that's one level of complexity. If you're going to spin up 1,000 containers, which may or may not be too many depending upon the size of the training you're trying to do, you have to pass back the IPs for all 1,000 of those containers to your master. It gets more complicated then because the workers need to know about the location of the parameter servers. So now you've got this couple different levels of hierarchy, all of this networking information that needs to be passed around. Then the other thing is, remember I said that Kubernetes will do software-based load balancing? It reserves the right to take down containers, move containers amongst the different pieces of hardware at any point in time and shift those IPs. So trying to take something like, for example, distributed TensorFlow and just throwing it directly onto Kubernetes, it's not going to work for you without a considerable amount of manual effort. Okay, so that's challenge number 1. Challenge number 2, I love this one. Kubernetes doesn't know machine learning any more than it knows any other sort of application, right? It's general purpose software. As a result, suppose you do spin up those 1,000 containers. Maybe some of them have GPUs, which tend to be very expensive capacity in most organizations. Your training finishes, it doesn't turn off by default. There's, Kubernetes, it doesn't know when you're done, it doesn't know when you're starting, all that sort of stuff. This is your custom code. You would have to account for this yourself. You leave a bunch of GPUs running in the public cloud, you're going to get a heck of a bill at the end of the month, right? So that's your next challenge. By the way, this is probably, well, I was going to say this is the most compelling reason for Kubeflow in most organizations, but actually the most compelling reason in most organizations is challenge number 3. Everything starts wide open. So Jupyter notebooks, which is what most data scientists do their work in. That might be an exaggeration. Let's say many data scientists do their work in. Open by default. Model storage, the places where the trained models get stored, also open by default. Network calls, unencrypted by default. Network addresses and ports, unauthenticated by default. This is sort of going back to the concept that, I'm told that 60 years ago, Unix systems didn't have passwords just because this was sort of lab stuff. Scientists working collegially, they trusted each other. Very much sort of the norm in machine learning technologies today. And sort of also the norm in Kubernetes. It doesn't, you have to do things to make it secure. It doesn't typically ship that way out of the box. So with those three challenges, how does Kubeflow help? So Kubeflow is an end-to-end lifecycle orchestration tool for machine learning. Question is, what does all of that verbiage mean when it's at home? So the idea or the vision is quite simple. Show of hands. How many folks in the room are software engineers, programmers? All right, excellent. How many come from the data science side of the house? Okay, a couple data scientists. All right, so as software engineers, we have had continuous integration for years and years at this point. And the idea is I write a little Java code, I write a little .NET code, I might even write a little bit of Python code, whatever. I check it in, some process in the organization picks that up. If it's compiled language, compiles it, runs the right kinds of scans on it, whether it's security or code quality, what have you, and then after building it and signing off that, yeah, this code is good, puts it where it needs to be, production, UAT, whatever. The vision is to do the same thing for data scientists. Let the data scientists who are sitting there working in their Jupyter notebooks, when they're ready to do a training, don't have them have to go to a human being. Basically give them the ability to say, all right, I want 100 CPUs and 2 GPUs, hit a button and have it go and do that. And then most importantly, when it's done, have it turn it off. And they get the bill for the capacity that they used. Enabling technology is Kubernetes. That's the kube in Kubeflow. The flow, however, is not meant to imply any sort of mandatory tie to TensorFlow. It's more of a sort of shared origin that the flow in TensorFlow and the flow in Kubeflow both refer to the flow of data across tensors in order to evolve them and basically train a model. Kubeflow works with PyTorch. It can work with scikit-learn. It's very sort of technology agnostic. So first, is the concept of secure Jupyter notebooks. So there you go, Jupyter Hub, username and password. This is Kubeflow version 0.4. They were still using Jupyter Hub. As of version 5, they moved to sort of an indigenous custom technology for serving up those Jupyter notebooks. And one of the nice things about this for the enterprise is that Kubeflow, there are some add-ins for it, which I'll talk about shortly, which allow you to tie that to the Active Directory within your organization out of the box. So whatever sort of authentication scheme your enterprises are using, you can just spin up a bunch of Jupyter notebooks for your data scientists. Pretty much, boom, just like that, as soon as you get the software installed. TF job, and I apologize for the smallness of the font. You'll somewhat have to just take my word as to what this says. But TF job is the other core innovation. So what TF job does is it says, you're the data scientist, you want 100 instances of the container that's going to run your training job. Rather than spinning up that container directly, you spin up, or rather Kubeflow under the hood spins up TF job, and TF job is the thing within Kubeflow that monitors and manages the 100 instances of your training job through to completion. So you can sort of see in there the bits that have like the double curly braces on either side. Those are the bits that get swapped in with the particulars for your application. And what this does is, this is the secret sauce that knows how to, at startup, record the IPs and the ports of your workers and your parameter servers or whatever the other pieces are that your particular data science framework needs, and pass those back to the master and even propagate those around the different workers and parameter servers. So as things move around, TF job is watching their network location and making sure that that information gets back propagated. So TF job is in many ways sort of like the core enabling function of Kubeflow. Ferrying attributes. Can everybody see, let me jump over here for a second. Can everybody see this line here? Good? All right, excellent. Oh, I just realized that's there because it's a leak. I thought it was for garbage. All right, so what that does, so this is like code like a data scientist would be creating. This is basically, you know, Python inside of a notebook. But what they give you is they give you this library called Ferrying, and within Ferrying are some attributes, and in this case, they're using the distributed training attribute, and if you look at the parameters on that attribute, it has worker count equals 1, PS count equals 1. This is how you can declaratively say, here's how much capacity I want you to give me out on my Kubernetes cluster. You run this, it just happens. It just goes out on the cluster and it does it. The data scientist didn't have to go and ask any engineer to get involved. This is all straight through processing. All right, so I actually added this slide last night because it occurred to me as I was watching Arun's presentation. I didn't actually have a slide in here that says how you get the darn software, which is really important. So to begin with, you download KF. So I don't know if everybody's familiar with the nomenclature here, but you know, typically kubectl is referred to as kubectl. So that's the reason why KFCTL is referred to as KFCtl. You download KFCtl on a machine that already has kubectl installed and running. So basically you're going to go to one of the control instances in your Kubernetes cluster that's already running, and you download out of the Kubeflow GitHub repo this KFCTL tool. You unpack it, you run KFCtl init, and then the name that you choose. If this is your first Kubeflow instance, chances are you're just going to call it Kubeflow. Whatever name you choose, that's going to become a self-contained namespace in your Kubernetes cluster, and that's where all of the Docker images are going to run for your Kubeflow installation. It also creates a folder. All right, you cd into that folder. Now you run kfctl generate all -v. What this does is it goes in under the hood and it configures all of the YAML that your installation is going to need in order to put Kubeflow up on your pre-existing Kubernetes cluster. So what it does is it basically interacts with the kubectl configuration files, and it says, okay, this is where this person's Kubernetes cluster lives. Here's all of the parameters I need to swap into these YAML files in order to get them set up. Then last, you run kfctl apply all. That's what actually goes through and it starts putting Kubeflow up on your internal Kubernetes cluster. What is Kubeflow? It's basically, in versions 0.4 and 0.5, it's about 20-some Docker images running in Kubernetes. That's what makes all of this magic happen. And there are images that do different things, like there's some stuff for TensorFlow, there's some stuff for PyTorch, there's the TF job stuff, and there's the stuff that actually manages your pipelines, which is what we're going to take a deeper look at. All right, so let's talk a little bit about exactly how I'm going to do the live demo today, or hopefully do the live demo today. I've installed a piece of software called MiniKF. MiniKF is completely free. When you go out to the GitHub repo for Kubeflow, you will see MiniKF up there. I'll be honest with you, MiniKF is the absolute most flawless experience I've had trying to install any of the varieties of Kubeflow. And you can go to my blog and you can sort of see the sort of details of all the different experiences I've had. I have never tried to put this against Google's public cloud infrastructure. My suspicion is that's the one that probably just works flawlessly out of the box. But MiniKF also works flawlessly. And what this is it uses a technology called Vagrant. Show of hands, anybody worked with Vagrant before? All right, just a smattering of folks worked with Vagrant. So basically, Vagrant is a tool that will, in this case, go out and pull down an entire virtual box that already has Minikube installed on it, and on that Minikube is installed Kubeflow. So that just about fits on my 16 gigabyte, 1-year-old Mac OS. If I had 32 gigabytes, it would work even better, which, you know, the fact that 16 gigabytes is why I'm going to show you pipelines, but I'm not going to show you the actual Jupyter Hub notebooks. That would be a little bit too much. As you can see, you know, different points here. One of the nice things about MiniKF is this will allow you to get stuff up and running on your desktop, and then you can just take that same code, you can put it and run the same Kubeflow stuff in production. Gave you the link to get it. It's contributed by Arikto. And the reason I wanted to specifically mention that was I mentioned maybe about 10 minutes ago that there's a plugin that'll allow you to take the Jupyter Hub and integrate it directly with Active Directory, so you can just have authenticated access to your Jupyter notebooks right from day one. They're the folks who make that. So you can look them up and find out about that. All right, so the demo has 5 steps. And let me see how we're doing for time. Yeah, we got plenty of time. Okay, so the 5 steps we're going to go through. Download. It's going to go out and it's going to pull down these 70,000 images. Remember the 10 different kinds of clothing and their labels from the internet. We have a pre-process step that's going to turn the arrays into 28 by 28 matrices with values 0 to 1. Okay, so going from arrays into matrices, that sort of makes intuitive sense for images, right? Because images are matrices, they're not, flat one-dimensional things. Value 0 to 1 instead of 0 to 255, this is just normalization, right? Standard step in machine learning is you try to normalize your data so you're talking in common terms, you get everything between 0 and 1, so we're going to do that also. Training, we're going to take 60,000 of those images and pass them through a neural network, and we're going to train up that neural network to be able to recognize these 10 different kinds of clothing. Evaluate, we'll then take 10,000 of those images and labels and we'll pass them through and we'll see how accurate our model is. And then serve, we're going to take that model and we're going to push it up to TensorFlow serving, and I'll actually get a prediction back from it. Okay? Now, demo architecture. And that is quite small, so I'll just try to describe it. So the outer box is my laptop. Okay, so that's physical hardware. Inside that we have VirtualBox running, and its virtual IP is 10.10.10.10. So this is an Ubuntu server basically running completely virtualized on my Mac. Within that VirtualBox, we're running a few things, one of which is MiniKube, so that's our Kubernetes cluster. And then I'm also running something called Minio and something called TF Store. So MiniKube, Kubernetes cluster, that's pretty straightforward. What is Minio? Minio is an S3 server, completely open source, free, that you can download. Why am I running my own S3 server? One of the interesting things about Kubeflow pipelines is that they don't, at least as of this version, give you a way to pass large amounts of data between the different steps. Each step of a Kubeflow pipeline is a distinct and separate Docker image that gets downloaded and executed. And the only state that it can really pass are short strings, because it will basically output a string, and then you can take that string and whatever you do with it, you can either use it yourself or you can pass it to another image. But all it's going to do when you pass it to another image is it's going to come in as a command line parameter for whatever script that image kicks off. So your opportunities for passing around things like a fully trained model or 70,000 images are few and far between. So what I'm doing here basically is I pull down those 70,000 images, I stuff them into Minio S3 storage, and all I do is I keep the S3 keys, and the S3 keys are what I pass to the next step, which the next step is pre-process. Pre-process pre-processes those images by turning them into matrices instead of arrays and normalizing the color scheme. It pushes the normalized images back into S3, and it stores the keys. Then we go into training, where we pass through all the training images and training labels. We get back a trained model. We push the model into S3. We just get back the keys. And then we pass the key to the trained model along with the test images and the test labels to our final step, which is evaluate. It pulls them out of S3, does an evaluation, and then it takes that model and it pushes that all up into TFS base. Last question before I actually show you this. What is TFS base? TFS base is a custom Docker image I created which wraps TensorFlow serving, because remember I said that everything is sort of open by default. TensorFlow serving is no exception to this. There's no authentication that's built into it. Also, there's not really a built-in way to take a model and push it up to TensorFlow serving. You have to build your own mechanism for that. So what I've done basically is I've taken TensorFlow serving and I've given it a RESTful endpoint that when I call it will tell TensorFlow serving, please go to S3 and pull down a new version of the model and serve that up. So that's the way that we get our model served up. So without further ado, We got 20 minutes. Let's take a look at some code. All right. So the first thing I wanted to show you is the Kubeflow user interface. So admittedly, this isn't the prettiest thing in the world. They'll do the nice graphical niceties in a later version, I'm sure. What do we have here? We've got a link to the Kubeflow documentation, always handy. We've got a link to the Jupyter Hub interface, so this is where your data scientists would spend most of their time. We've got a TF job dashboard, so that's where you can go as an operator and look to find out all of the trainings that are running at any given point in time. The Khatib dashboard, which if there was one thing I wish that I could cover in additional depth in this, it's Khatib. Show of hands, anybody worked with Khatib before in the room? Okay, so particularly the couple of you who are data scientists, you should definitely check out Khatib. It is very slick stuff. It does hyperparameter sweeps. So this will basically help you figure out, like say in a neural network, how many layers would be optimal, how many neurons should be in each layer, all that sort of stuff. Very cool stuff, but beyond the scope of this session to cover it, because this is really focused on the DevOps side of machine learning. Then we've got the pipeline dashboard. So let's hit this. And these are all of the samples that come actually with Kubeflow in terms of pipelines. The thing about this is there are two varieties of pipeline here. A couple of them are self-contained and run on a local Kubernetes instance, but they're trivial. Like they just show you how to do like an if branch in your pipeline logic, for example. Then there are a couple that are really meaty, and they show how to do like GitHub issue summarization and taxi fare prediction and all that sort of stuff. But the problem is those are built to run against Google Cloud, so you can't just run those. I would never personally try to do a demo against a public cloud just because, you know, it's internet connection, all that sort of stuff. So what I have built, and what I'll give you the link to the GitHub for, is a fashioned MNIST pipeline, which the way that these pipelines sort of look, if I show you like a former run. So this is a run that I had done previously. Remember I said that there would be download, pre-process, train, and evaluate. This is a former run of my fashioned MNIST Kubeflow pipeline that has download, pre-process, train, and evaluate. Now, really important thing I want to convey to you about reading these, don't look at these arrows and think of these as control flow. Because if you do, you're going to be really perplexed by how control passes out of download 3 ways, and then it goes to train, but it also goes to pre-process, blah, 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 blah. This is not control flow. This is data flow. So what this is basic, and also the other thing, not only is it data, but it's consolidated data. So let me sort of walk you through very quickly what this is telling you. So we download 4 things off the internet: training images, training labels, test images, and test labels. What this is saying is, and I'll use this arrow to sort of point, this arrow is saying both kinds of images come out of download and go into pre-process, because we have to pre-process the images to turn them into matrices and to get their color schemes right regardless. Now, the training labels go directly to the training step, and the test labels go directly to the evaluate step, okay? But then what we wind up seeing is the training images come out of pre-processing and go into train. So train is basically getting the training images plus the training labels. Evaluate is getting the trained model, the test images, and the test labels. Now, when I realized what this was, the first thing I did was file a PR with Kubeflow to say, I really feel like these labels should be these arrows should be labelable, right? Because this would be a lot easier if you could actually look at these labels and see what kinds of data each one of these are. It's not there yet. Hopefully it will be soon, but that's what you're seeing here. The green check marks mean this is already run. And one of the nice things is Kubeflow keeps a history of all of your former runs. So you can click it and you can click logs and you can see back when I ran this 2 weeks ago preparing for this demo, here's exactly what came on standard out during that run. And here's what happened for pre-process. So I want to show you one thing quickly while we're on pre-process. I add a little something into the pre-process step, which is this output. What this did is it grabbed one of the images and it showed me exactly what the JSON message is I need to pass to TensorFlow serving in order to ask TensorFlow serving to identify this image. What is that image? It's this guy. Hopefully this will launch. And I know that's way too small, so I will blow this up. All right, I think we can all agree that this is a sort of stylized pair of pants, right? Okay. So the goal for this at the end, by the way, is I'm going to pass this in and we're going to have it say, hey, that's a pair of pants. But you get the general idea, right? Okay. So let's see. So that's, one of the things I'm going to point out in the pre-process stage. Train, you can see this is where it went through all of these epochs and did the training. And then in the evaluate, it basically passed in those 10,000 test images and their labels. And we came back with a 0.87, 0.86 accuracy. I'm going to go ahead and try to actually kick a new one off. So I'm going to upload a pipeline, choose a file. The file is this guy. And I'm going to show you exactly how that, how we got that momentarily. But I'll choose that. I'll give it a name. We'll call this GOTO Conference. We'll upload that. Boom, here it is. And now we'll create a run. So runs have to be parts of experiments. Experiments are just groupings of pipeline runs. It's just a container. There's no significance to it really. So I'll call this run demo big live demo. And we'll choose our experiment. Well, there's only one experiment, which is demo run, so we'll use that. And then the thing I want to show you, and I'd like you to try to remember this, I'm going to switch this full thing to say half, and notice that this says download and pre-process. So what is this? This is what's called a pipeline parameter. So another feature of the pipelines is you can pass in data at runtime and use that to influence what happens in your pipeline. So for example, if I want to do one run that has maybe 5 layers in my neural network and another one that has 10, I could have a pipeline parameter which is number of layers. If I could have a pipeline parameter would be number of neurons per layer. I can switch things around. This is how you change parameters at runtime. So having said that, I'm going to go ahead and kick this guy off. And the first thing you see is that it goes to status unknown. This is our former run. And we'll choose this guy. And one of the things it loves to do is just sort of take its time getting started, so that those of us who are giving live demos have a small heart attack, but that's fine. All right, refresh. We're off and running. The other thing you might notice, there's a refresh button. So it's refreshing to see a refresh button. We haven't seen that in a long time. Most things are push model nowadays. You gotta hit refresh periodically to see how stuff updates. So download's already run, and I'm going to show you something. So I go to logs, and in this case, let me hit another refresh. It just has one line. Remember, when I did download before, it had a lot more lines than that. When I go to pre-process, it only has one line too, and yet in both cases, it's saying it's done. So what went on? Let me loop back and show you a little bit of the code to show you what a pipeline actually is. A pipeline is just a Python script that has used a special extension, a library called KFP, Kubeflow pipelines.dsl, and there are attributes in here that you can use to give names and descriptions, and boom, boom, download and pre-process. Remember, that was the name of the parameter I passed in. Anything you put in this collection is going to be a parameter that you can pass in. Let's take a look at each one of these steps. You add a step to the pipeline just by instantiating an instance of dsl.containerOp and giving it a name. So let's look at this. We've got download, we've got pre-process, we've got train, and we've got evaluate. If we go back to the user interface, download, pre-process, train, let's do a refresh. Yay, the whole thing ran. Train and evaluate. Now if I look at train and evaluate, they've got full output. So what actually happened there that we only had truncated output for those first? Remember how I switched it from saying full to saying half? Well, what I did was I coded up, so each one of these steps is a Docker image, and you pass in an image attribute for each one of these objects that tell it exactly where to find the Docker image and download it. And in the code for each one of those, I basically started it off, and maybe we can take a quick look at an example. I don't expect anybody here to be like a Python expert or anything, but let's see, right towards the top. I say if the argument that got passed in is full, then do stuff. Otherwise, it basically bails on it. So I'm basically querying that pipeline parameter that got passed in, and in the download and pre-process steps, I'm saying if they passed in something other than full, just bail on these steps as soon as they start. That's a way that I can rerun just a part of my pipeline, and in this case, the part I wanted to run was everything after downloading and pre-processing, because honestly, why do you need to do a pre-process and a download, more than once? So if we go back to the code for a second, I want to show you more about this. So you pass in the name, you pass in the image, and then the other things you can pass in are an argument. So here's where I'm passing in that full or half. And what you get out of it are a set of outputs. And the way that you get outputs is you specify the name of a text file and a label. And what this is telling Kubeflow to do is, it's saying, hey, you can count on this Docker image when it finishes to have created a text file at this location. I want you to pop that text file open, read its contents, and stuff the entire contents into a variable called this. So if we go back and we look at the end of our download thing, sure enough, download ends by creating 4 text files and stuffing data into them. What are we actually using that for? These are our S3 keys for where we've stored our images and labels, and we pass those to the next step by using the outputs collection of the previous step, which was called download. And these are the labels from there. So you can sort of see them moving across from one step to the next. All right, so that is a pipeline, the construction of a pipeline, and I guess the other thing I want to show you is an actual prediction. So for this, so what's happened now is it's basically trained that model and it's put it in S3, then it called a RESTful endpoint, and TensorFlow serving knew to go and pull that down out of S3. Here's the body of the message, which is a whole bunch of numbers, which are the numbers that are basically in that matrix representing a pair of pants. And I'll go ahead and I'll send this JSON message in. I've got my credentials in there also. And let me see, maybe I have to, there we go. I've never worked at this lower resolution before. So what we can, there we go, excellent. So here is the way it returns, and this is very TensorFlow centric, so I won't go into too much detail on this, but what this is basically saying is, here is a probability that the image you've passed me is each of these different kinds of clothing. And notice that all of these are very small numbers until you get to the last one, which it gives 88%. Number 10 is basically pants in this nomenclature, and I just happen to know that. So it's basically saying, yes, these are a pair of pants. And actually the distinction, I believe, is between dress slacks and jeans. So it kind of makes sense. It basically said, look, there's a 10% chance that it's jeans, but there's an 88% that these are dress slacks, which is what they are. All right, so last bit of content then. Some additional points of note that I really want to convey in the last 1 minute before we take questions. I already talked about securing the prediction layer, securing S3, lots of different ways you can do it. Minio just takes a username and password. Lots of technologies out there for putting that in a vault. Kubeflow doesn't do that for you, so that's one piece you have to do on your own. On-premise issues with setting up Kubeflow. Container lifespan limitations. If you're running in a big enterprise, your enterprise probably has already worried about people leaving containers running and running up bills. So be aware, if you find your containers turning themselves off after, like, say, a week or whatever, and you're trying to do a 3-week training, check with your administrators to make sure they don't have like a kill switch put in there that kills your containers. Kubernetes action limitations. Kubeflow needs to be able to create and configure access to namespaces. That's the way it does security. So you have to run Kubeflow using an account that has permissions to do that sort of stuff. Otherwise, it's not going to work. These are, by the way, the sorts of things we're sort of, working with in City Scholars. And then procurement challenges, a couple of really important ones. That KF cuddle thing I told you, how does it work? it goes out to the live internet and it grabs down Docker images and pulls them live off the internet and stuffs them into your Kubernetes cluster. So if that's the sort of thing that your enterprise has issues with, you're going to need to do a little bit of coding around in order to point that at your internal Docker repo. You should have an issue with it actually because as of right now, in our research, we found 3 Docker images that have had security vulnerabilities in them. So another thing the community is working on, I think, is trying to get some security scanning set up around these images to make sure that the stuff that's out there doesn't have known vulnerabilities. In conclusion, there's the link to the source. There's my email address. Any comments, questions, or concerns? Like I said, this stuff is like my bread and butter nowadays, so always happy to chat with anyone about it. Feel free to ping me. Or LinkedIn. I think on the app there's a link where you can just hit to link in, so we got time for questions.